The International Space Station crew members, as we've seen, have been working on a variety of experiments that are focused on the human body today. But the space station is also a test bed for new technologies. Today we can learn a little bit more about an ongoing technology investigation that could help us when traveling much deeper into space. Let's go to the Payload Operations Center at NASA's Marshall Space Flight Center, where Lori Meggs is there to tell us more.
Learning ways to filter and renew cabin air is one of the objectives of the Amine Swingbed payload. It's vital to deep space exploration, especially if we want to cut the demand for resupply of the essentials.
Amine Swingbed is a technology demonstration of a carbon dioxide and water removal system. It's the baseline technology for the Orion program for what they want to use to control carbon dioxide humidity levels on the spacecraft. We're testing it out on the space station to see how well it performs in the microgravity environment, but also to understand from the ground what it takes to operate a payload. A lot of our people in our team are technology developers and really don't have a good insight into the ops world. And so this is a great bridge for technology people to see what ops is all about.
So how does it work?
So the way that it works is cabin air is forced through our swing bed. There's a bed A and a bed B, and this filled with sorbent media, and the cabin air contains carbon dioxide and humidity. Carbon dioxide and humidity sticks to this sorbent media and on one bed, while the other bed is exposed to space vacuum. And so a valve controls the airflow between one bed and the other, and every so often, every 6 to 20 minutes, the valve rotates, changes positions, and then the bed that was loaded up with all that carbon dioxide and humidity is then vented out to space vacuum. And so this is a process that is regenerable. We don't save the carbon dioxide and humidity, but the sorbent media can be used for a very long time.
So how does this help with future exploration?
So this was a demonstration of the technology that Orion plans on using for their main system for controlling carbon dioxide and humidity. And the additional things that we added into it, water save functions and air save functions, were very specific to originally an ISS application because they don't want to lose a lot of water vapor. Yeah. So these new components that we added involving a desiccant system, that would be able to be applied to missions that are of longer duration than, say, Orion, when you want to start worrying about how much water vapor you're venting overboard.
How long does this demonstration last?
Well, the science started back in May of 2013, and we just finished this past February. In terms of collecting the science, we did 1,000 hours of operations. The experiment, however, is going to be staying on longer because we provide a capability. We can scrub carbon dioxide when other systems may be needing maintenance or something. We can provide contingency support. So it's really up to the program how long they want us to stay up there.
Did any of the work in Huntsville at the Payload Operations Integration Center, did you work with them any?
Very closely. And I think one of the things they started doing recently was dedicating a team just for our payload. So rather than a payload operations manager working over a variety of payloads, we had one particular payload operator or operations manager that was for us, as well as they helped write all of our procedures to turn them into the official format that they need to be. So we work very closely with the folks at Marshall to operate this payload, as well as getting it up on orbit.
And taking a live look, they are working with the Amine Swingbed folks this morning. It is active, and they are doing their part to assist there. Craig Cruzen is the Payload Operations Director today, leading the team. Now later today, they'll be doing some work with the Opals experiment, and that's the laser communications experiment. So a lot of work going on today, busy here in Huntsville as usual. That'll do it for us here at the Payload Operations Integration Center. Now back to you at Mission Control in Houston.